Okay, welcome to today's tutorial. We'll be going through switch statements and functions. Not sure if we need anything else, but yeah, I think that should be fine for today's session. So let me open code blocks. Yeah, after we've done with yeah, we're supposed to cover type def and record structures. Yeah, we'll have a session on a separate session on that. So we'll have the session tomorrow on the record structures and what is this? Record structures and what? And type def. But the record structures, to be honest, they won't take a lot of time to explain. So I'm going to create a console application. C++ is the programming language. And then today is switch statements and functions. Right? Then I save it in that folder where I save all my C++ projects. Then I'm going to view my name. You see, now it's muting itself. I don't even know what's going on now. Let me just quickly check. Why is it muting itself now? Muting options, audio. Yeah, there's nothing wrong. I don't know why. From time to time it does that. I guess maybe it's my laptop starting to become old. I don't know. But yeah, let's start with switch statements. So if you recall, we talked about if statements, right, in yesterday's session. We talked about if statement, we talked about the different operators that we have. We have relational operators, we have arithmetic operators, we have okay, yeah, we have what's the other one? Logical operators. So if you still remember if statements, we're gonna do just a revision on that, right? So let's say you have a let's make it unsigned, right? Meaning you can only store positive numbers. So unsigned int, it's a positive integer, meaning that it ranges from 0 to positive infinity in a way, but it's not really infinity because we can't represent infinity in a computer. So it's some number, just know it's some number, but it's a big number. It's around the billions there. So unsigned int, I'm gonna say this is your mark, right? Maybe it's a practical mark. Then I'm gonna initialize it. I could initialize it this way, or I can say equals to. That's up to you. Like I said, I like to use this list initializer syntax. So here I'm gonna specify the value for it. Let's say this is your practical mark, right? Or let's say it's a semester mark. It could be semester mark, can be any example. But I'm gonna choose this is like let me see, this is your final mark, right? Let's say you got you did very well, you got 95%. That's your final mark. Then now we're gonna we're gonna assign a grade letter. So this is how we're going to assign the grade letters, right? Let me do this. So this is how we're going to assign the grade letters. So if we have 90% and above, right, it will be the letter A. So it's going to be, no, let's say A plus. In terms of A and, okay, I know this person has mic usually unmuted. Yeah, so we're going to choose, we're going to assign a letter for each grade. Let us assume that you only have A, B, C, D. There's no E, but then there's an F. So A, B, C, D, and F, right? I'm not sure about D. Yeah, D, there is a D. Yeah. So we're gonna have this. Then if you got 80% and more, but it's less than 90, right? Just know the difference. I don't have to specify the ranges, but for the sake of clarity, since you guys, so this will be just to infinity. Not like I said, there's really not infinity in computers. So let's just say 0 to 90 to 100, right? 90 to 100. Then this one will be 80 to I'm starting to regret making this example. Let me think about it. Yeah, yeah, this example wouldn't suffice to demonstrate what I want to demonstrate. Yeah, it wouldn't work. Yeah, it wouldn't work the way I want it to work. Yeah, it's not gonna work the way I want it to work because I want to demonstrate switch statements. So let me try a different example. Let's say, what example can I try? Let's say let's keep it short, right? Short and simple. If your mark is 100, let's say okay, let's look at in terms of minimum marks. If your mark is 40, you failed the module, right? If your mark is 50, you've passed the module. Simple, right? So 40, if you get 40 on the dot, right? Or 40, between 40 and 49, bro, it depends on the module. But in this case, imagine that's the example. You failed. And then if you got 50, you passed. The thing is with switch statements, right? You cannot specify ranges. That's the problem with switch statements. To specify a range, you have to actually list the numbers individually one by one. So what do I mean by that? For example, you want to specify the range from 90 to 100. With switch statement, you have to say case 90, case 91, case 92 until you reach 100. That's actually how you do it in a switch statement. That's why I removed that example because it's going to be, excuse me, it's going to be very hard and unnecessarily complicated for just to demonstrate a switch statement. So that's the requirements, right? So let's start with if statements so that I can show you how it looks. Okay, let's say if you got 40, you've passed. If you've got 50, you've passed, right? Okay, let me say passed with, I don't know, is it a D or something? Then let's say you got 60, you passed with C. Admit. Then you passed with level C. These are just examples, right? If you really want to follow the rules, you have to use if statements. This would be a B, and then let's say you get any 80, just say 8 in general. 80 passed with A, right? So this will be the example. So to translate it to code, I have to take a variable first because I need to check that variable's value, what is inside the box. So I'm going to say if mark, right? Remember, we're trying to check if they're equal to, if mark is equal to these numbers, any of these numbers. So to check equality in C++, remember we talked about it yesterday, we use two equal signs. So if mark, which is going to be my left-hand side, is equal to my right-hand side. So what is my right-hand side? 40. Then I'm going to do something, right? So basically it's an output failed. Then I'm going to repeat that for all the other statements. And if you look at these values, right, this is one condition, this is another different condition, another different condition, another different condition, and so forth. They're all different conditions. We talked about if statements. If you have different conditions, you use an else if, which just simply means if this is not the case, meaning this is false, else check this if statement, check this condition. But then that condition over here should be different from this condition over here. So if mark is equals to 50, and then else if mark is equals to 60, and then else if mark is equals to 70, and then else if mark is equals to 80, right? Then that'll be the last one, but I'm gonna change up this. I'm gonna switch it up a bit. I'm gonna remove the if is equals to 40, and instead I'm gonna use an else. Remember else, it means it's none of the above conditions, meaning it's not 50, it's not 60, it's not 70, it's not 8. It can only be what? 40. But then I'm gonna put an else case there, just on paper so that you can kind of see what I'm trying to, because I'm gonna try and translate this back to a switch statement, right? So remember, this is the outputs. This is what you're going to print. So I'm going to say cout passed with D, right? So passed with D. Then I'm going to put a \n, right? To make my output beautiful. And just look at how everything is aligned. You see how everything is aligned. Very important. Then B. Then A, right? Then this one is it should just simply output failed. Right? It means you failed the module. If we look at the value of mark, it's what? 50. So the output that I expect to see is passed with D, because that's the first true statement or true condition. If you have multiple if statements like this, right? C++, the way it does it, it checks for the first true statement, then it runs it. As long as it hasn't found a true if statement that's true, it's gonna keep searching. If it eventually doesn't find any condition that's true, it's gonna look for an else. If there isn't an else, it's just gonna skip and continue to the next code to run. So that's basically how if statements are going to work. So if I run this, I should get that output that I'm expecting, which is passed to D. So you see, there's the correct output. I might have to demonstrate it a bit, right? So let me zoom out a bit. So you see, there's the code, right? There's the full if statement. So now I'm going to show you in terms of diagrams, right? I know this might take a lot of time, but it's cool. I just want to demonstrate the diagram, the flow chart. How is it going to look? Apparently, I don't know. I'm not a person who usually does designs because that should be straightforward. It's on the slide. When you do past papers, I'll do one design, one. The person who has his mic unmuted, please mute. So I'm gonna demonstrate. I'm gonna need a diamond here. So the diamond, right, in terms of the diagrams, it represents the question or the condition. So here we're gonna put our conditions. So I'm gonna start with the first condition. So the first condition, it asks if mark is equals to 50, right? That's the question that's being asked. At least I have somewhat of experience in this thing. I'm getting better every day, but I'm not perfect yet. So I can make it look presentable a bit. Yeah. So this will be a question mark here because we're asking if mark is indeed equal to 50. Then the way I do my diagrams, right? And that's the way most people are gonna do it in the industry and things like that. You're gonna have the true branch and the false branch, meaning if this question is false, do something. If it's true, do something. So that's what I mean by that. So I'm gonna have here, if it is true, I'm gonna have this side. Okay, let me delete that. And then copy this, then put it somewhere here. So this is when it's true. It doesn't matter what order you put it in, it doesn't really matter. Then we have also when it's false, which is this side. So we choose a specific direction to go based on the truth value of the question. If it's false, then we handle the false part. If it's true, and we handle the true part. So now I'm going to demonstrate this. So yeah, so I'm gonna need text again, right? So here, if it's true, I'm gonna put some text here. This should output passed with D, right? If it is true that you got 50, that means you passed with D. So I'm gonna choose a random color here, then I draw a line, right? So this will be the true branch or the true, we call it the true branch. Basically the side whereby we're gonna handle when the question or the condition is true. So I should actually phrase this to output passed with D, right? Or you can say print that text, that string, doesn't matter. So we have this side if it's true. If it's false, what do we do? remember we check another condition if it's false. So yeah, this diagram is going to be quite a long diagram. So if it's false, we go here and we check a different, we ask a different question. That's what the else if means. It means we're asking another different question. So what's the other question? Is that is Mark equals to 60? Right, I'll share the diagram in the group. Remember, I always send you guys the diagrams. Don't worry about the diagrams, we'll send them. Let me just use the same color for my questions. Then we're gonna have a true and a false branch. Basically, true and a false side. Meaning, if it's true, do something when it's true, and then if it's false, do something when it is false. So I need to copy this. Right, so I'm going to put it this side. I advise you to take a careful look at this diagram if you really want to understand if statements and switch statements. They basically work the same way. Just that one makes the code kind of look neat. That's the only reason for switch statements. It's just for the aesthetic. So we have true and false. So if it's false, remember, if it's false, we ask another different question. You'll see at the end of the day, we're going to reach a stopping point, but we haven't reached the stopping point yet. So I need to come here and copy this text, put it down here, right? Then I'm going to draw some line over here. Right, so this is when it's true. You should output some passed with. Okay, let me select this and choose a different color. So here should output passed with C, right? When the condition was true, meaning the mark was equals to 60. That means you got 60%. This is just an example, right? It's not something that's actually true. It's just an example. So then I'm going to have this side another question, right? So I'm going to have another line over there. Then this is false. Then now the next question is it equals to 70? If it is equals to 70, then we do something again. So you see, I'm sure you can see the diagram. You see how it flows. You ask a question. If it's false, you do something else. If it's true, you do something else. So that's basically how the diagram will look like. In order to understand why it's called a branch, right? Why we call this true part or this false part, why we're calling it a branch. If we were to flip this diagram upside down, it will actually look like a tree. So that's why we call these lines branches, because it kind of looks like a tree when it's flipped upside down. I'm teaching you I'm giving you a lot of wisdom with this, because yeah, it takes a lot to be able to imagine it in that way. So we have this when it's true. So I need to copy that. Yeah, so yeah, we're gonna have to move a bit slow and for now, because I really want you to have this diagram so that you understand how you should come up with the diagrams and stuff. Basically the if statements. That at the end of the day is just diagrams. Then come on. Right, so this is true and then false. Then if it is true, it's going to output passed with the B, right? Here we're going to say passed with B. I'm going to say passed with B, then use a different color, right? Then put a line there to show that this is the branch for when it's true, right? That's the branch for when it's true. Then put that true there. Then move it just slightly a bit aside. Then we have another different condition, which is when it's equals to 8, right? So I'm going to have another different condition here, right? I'm going to align it. Then the question is now, is Mark equals to 8? So is Mark equals to 80, right? So there it is. Then I'm going to put in a line or to define the branch. So this is the false branch, meaning when the condition is false, we do that. Yeah, I'll just leave it as it is. So the question is it equals to 80? Then if it is equals to 8, we do something. I'm sure you can see the diagram, right? How it looks. It's actually neat. Yeah, because that's how things should be. Make sure your things are neat. If I was a lecturer, yeah, I don't think I should be a lecturer. I should stick to tutoring. That would be very harsh for me. I don't have time for games, especially if you're doing honors. Yeah, it's not gonna end well with you. And I'm your mentor. It's not gonna end well because I'm gonna need to mentor students who actually read the textbook and basically students who don't have a life. They don't groove, they don't do anything, they're always reading the books. That would be the type of student that me and that I would definitely get along with. And then we have this. Let me change this to different color. Let me choose this. So yeah, so we have output passed to D, passed to B, passed to A. Then we have the false part, right? If we go back to our if statement, if it's not this, that means we end up going to the else branch, meaning that we're gonna output failed. So that means I need to copy this, right, and put it this side over here, right, and say output failed. That's the string in my output. Then I need to use a different color. So let's choose brown. And then, so we have that, then put it this side. Yeah, then, yeah, there's the diagram, right? Obviously, you need to reach an end state, right? The thing is, I doubt I have the end state thingy. But it kind of looks like this, right? If you remember the diagrams you taught in class, it kind of looks like this donut shape. Is it flowchart? That's nah. I think it's this one, yeah. So it's this. So I'm gonna put it down here, right? I'm gonna put it here. Then after running every single statement, right, it's gonna go to the end, meaning the program is gonna stop. So this will be the end. So when it reaches here, this dot here, this circle, it means that the program has ended. And then if it goes this side, right, it's gonna end again. Then if it goes this side, it's gonna end again. Then if it goes this side, it's going to end again. And then if it goes that side, it's going to reach the end once we are done. Yeah. So that's the full diagram. So there's the full diagram. Then now I'm going to import it and save it inside Microsoft Word, but I'll do that after the session. So I'll save this diagram and convert it into a PDF. I'm going to use SVG, not PNG, so that when you zoom in, you can see and read the text. So if you can't see well, you can zoom into the PDF. So we already showed you the if statements. Yeah, you see, I already showed you the if statements, right? So now let's try to convert this if statement. You see, the reason why we need a switch statement, right? All of these things, right? All these else if statements. What if you have a lot of conditions to check? You see that your code becomes quite a lot. So that's why we're going to use the switch statement approach. So a switch statement approach, right? It works exactly the same way as an if statement, but then slightly different, the syntax. So you use the keyword switch because it's a switch statement. Then you put parentheses, right? Then you're gonna put in your curly braces that represents the switch statement, right? It's sort of if you remember, right? Sort of like an if, right? It's like you simply remove the if and put a switch. Then here, instead of passing something that returns a boolean, right? A bool, we pass something that returns a number. That's where we pass integers there. You cannot use a double simply because there's an infinite number of numbers we can represent between two doubles. If you get what I'm saying, right? So let's say you're trying to find how many numbers are between 15 and 15.0 and 20.0. You're trying to find how many numbers are between that, right? But then in order to find those, how many numbers are between that, you can also check how many numbers are between 15.0 and 16.0, which is 15.1, 15.2, 15.3, 15.4, and so forth, right? But then between 15.1 and 15.2, there's also other numbers like 15.11, 15.12, 15.13. So you see that there's an infinite number of numbers we can represent in a range, especially when you have doubles. So we tend not to use doubles in switch statements because of that. You can't possibly cover all the numbers. That's why if you try to pass here a double, it's going to show you errors. So here, you try to make sure you only pass integer types. By integer types, right? Bool, remember, we talked about Boolean yesterday in yesterday's tutorial. That Boolean is somewhat of an integer type because if you use 0, C++ assumes that's a false. But then if you use any number other than a 0, C++ assumes that's a true. Right? So that means that I can use bool here because it can return an integer. Then you can also use the char because remember characters in C++, when you're working with character data types, right? I think we should have another separate session for strings because there's quite a lot to explain in strings. So the char, yeah, I need to cover the string. Yeah, we need to do that. So the char type, right? In C, you remember computers, right? Everything is represented with the bits, which is binary digits, zeros and ones. So that means a computer speaks in numbers, zeros and ones. If a computer only speaks in numbers, then how can we tell the computer to store the letter A? Well, we can just simply assign that letter a number, an integer, then convert that integer to binary. If you remember semester test 1, question 1, and they're saying convert to binary to hex or all those things. That's basically what I'm talking about here. So there's something called an ASCII table. Basically, it's a table that contains the integer numbers that represent each letter of the alphabet. Basically, each symbol on your keyboard. If you look at your keyboard right now, all of the symbols that are there, they're represented in a table called ASCII. Right? It's ASCII like this. ASCII table, which is the American Standard and Code for information interchange, right? Something like that. That's what the ASCII stands for. Then char, then you can also use short, you can use int, you can use long. I doubt I've seen long being used, but I think you should be able to use it because that's also an integer type, a long. There's also long, right? Long. So I would say these are the data types you should mainly think about when you're working with switch statements, right? Don't try things like strings and what they don't do that. That's not a number. So make sure you understand this rule. You only use integer types. So the way it works, right, is you pass in a variable here. So you're gonna pass in a variable, right? Or an expression. It can be an expression, right? I think it can allow you to pass an expression there. But then that expression must return an integer result, meaning one number, right? So that's the main goal. But most of the time, we're going to use variables there. So I'm going to put mark, which is my variable. It's called mark. Then I'm going to have what I call cases. The cases, they're equivalent to conditions in a if statement. So when you say case, so remember we use 40 under the else part. So I'm going to leave that for later. So I'm going to have case 50. Hold on. Then I'm going to have a break here, right? Then, yeah, let me explain what's going on now. So C++ noticed, you're looking at you're checking what value does the mark variable has. So when you go to case 50, which is line 18, you are basically asking C++, is mark equals to 50? That's basically what you're asking. And then if it is, under this curly brace, under this colon, I mean, that's you're executing when it's true. Basically, when it's true that is equals to 50. And you need to understand something very important about switch statements, right? If you have one statement, remember if statement, I mentioned this thing that you can create an if statement like this, right? You can remove the curly braces as long as there's one statement. Even in switch statements, it's like that. You might actually get errors. A lot of you have been getting errors and you didn't realize what was the main error, especially when you're using switch statements. If you have one statement here, it's fine. You can omit the curly braces. But then you see there's already a comment here. So the moment I put in another line, now I have two lines. I have line one, I have line one here. This is line two. So now I need curly braces and put both of these lines inside curly braces because there's more than one. But if I had removed that comment, which I don't need, I'm just gonna say cout passed with D, right? So as you see, there's one statement, so I don't need to put curly braces. If there was more than one, I'd have to put curly braces here like this. And notice the style. Look at how clean my code is. Look at how smart my code is. Very clean. It's easy to read. You can tell these curly braces over here, they are for this case. If you had do something spiritual like this, how would I even know? That's why sometimes I get frustrated when students send me code because it's hard to read your code. I would have to literally start it from scratch, of which I don't have that time. Then I end up getting frustrated because I'm reading your code. So be 100% neat, especially if you know you're going to be sending me code. Make sure your code is neat. From now on, I'm not going to tolerate code that's not clean, that's not neat. Look at how neat my code is. You need to put the spaces at the right place. You see, there's a space again here so that it's neat. Then I'm going to have cout there. Then I can have another if statement or even for loop. I can have all those things for for loop and whatnot. I can have all of those other things. Then I'm going to undo this. I forgot to talk about for loops. You see, I keep thinking I did it with you guys and I did it with ComSci 2A students. We still have to cover for loop. There's quite a lot to cover. Eh? I think we're going to have to wait a bit before we do past papers because there's no point in doing past papers when you don't understand C++. What are you going to write in the past papers? Because in the past papers, they need C++, right? So we need to study C++ first. Then break, case 80, 50, 60, 70, 80, yeah. So this will be C, B, A, right? And it's exactly the same as this diagram of A, those set of if statements. But do you see how neat it is? I want you to notice the difference. Look at how small and neat this thing is compared to all those if statements. So if you have multiple else ifs, go for a switch statement always. Leave if the moment you're having multiple else if statements, don't create all those multiple else ifs. Unless if you have ranges. You see you have ranges, right? The problem with switch statements that you cannot specify the range. You cannot say from 50 to 100. You can't say that. If you want to say from 50 to 100, you must count. You must say case 50, case 51, case 52, case 53, case 54, until you reach 100. Do you see how much code you're going to have to write? So an if statement would be better in that case, especially when you have ranges. If statements, even if you're going to have a lot of else ifs, because it's actually your code is going to be way smaller than the switch statement. Why is it important to have the break? Right? You might ask yourself, why is it important to have the break? The break, it helps C++ to know that you're done with the switch statement. Then it leaves the switch statement, or else it's going to execute the following case, which is not what you intend to get, right? So let me show you what I mean. Remember, I put 50 inside this variable. Let me comment out this break over here. This is how C++ is going to work. It's going to be like, is case equals to 50? Then, okay, it outputs this. Then it's going to check, is case equals to 60? Then if it is, then it's going to output passed with C. Then it officially leaves the switch statement. Lucky enough, it won't print, right, to two statements. But most of the time it will, it did, yeah. as expected, but I don't know why it allows you to do that. It shouldn't. Yeah, it shouldn't. But you see the problem with forgetting break. It does something that we call a fall through, meaning that it falls through the next case, meaning it just simply goes to the next case without even giving you a warning because you forgot to put a break statement there. So that's why you're seeing the wrong output. You're seeing two outputs. The person only passed with a D, but then it also telling them that you also passed with a C, which is incorrect. Imagine how would you feel if this was your salary? Then they said, okay, we're gonna give you your salary, which is 30,000, right? Then it goes to the next case. Then they're like, oh no, we changed our mind. It's 15,000. How would you feel about that? Not nice, right? So we have to always put a break after every case, or else you're gonna have unpredictable behavior. So now when I build and run, it works perfectly fine now because it doesn't follow through or fall through to the next case. It doesn't go to the next case. So this is the switch statements. But you might ask yourself one question. What if all of these cases are false? Basically, what's the equivalent of an else? Well, there is something like that in a switch statement. We call it default. So you say use the keyword default, colon, and then you write the default. Basically, if it's none of the above, which is important for the none of the above. Let me show you if I don't put the default. Basically, there's no else. Basically, there's no, if you get 40, it's not going to output that you failed. Basically, it will have no output. Let me show you. See, no output at all, which is wrong because it was supposed to say failed. So we need to put an else in a switch statement. We do that by the keyword default followed by a colon, which is the same as like an else in a if statement. Then we simply output what you want to output. So cout failed. And then \n, right? Now when you run it again, it should output failed. You see, perfect. So if it's none of the above. By default, it means none of the above. So even if I change this to a 10, it's going to say failed because it's none of the above. So you see, failed. It's none of the above. It's default. It goes back to default. This is just an example, right? Don't overthink it. This is not how your marks are calculated in any way whatsoever. So don't worry about that. So now we are left with 15 minutes because I need to have a session with ComSci 2A students. So let's talk about functions. So with functions, right, this is the syntax. So you have the return type followed by a space. These spaces that I put in the comments there, they're also there when you're actually creating the functions. They need to be there. So return type space followed by the name of the function followed by round brackets, right? Then here we're gonna pass in parameters. Then semicolon, if you put a semicolon, right, this will be what we call a function prototype, right? Then if it has curly braces and you wrote code in between the curly braces, it's something that we call implementation, right? Meaning that we have written the code for the function. And the function you use is something that we call IPO. If you remember grade 8, grade 9, somewhere there. IPO, input, process, and output. Input, right? What is input is the things that are incoming, that are entering into the function. These are, they're entered via parameters. Then process is the code. You see, when I talked about the implementation, basically when it has curly braces, the code in between the curly braces, that's the process. Basically what the function does. Then output is basically what the function gives you back. So it's like, for example, a blender can count as a function. The name of the function would be blender, right? Because it blends things, right? Then the fruits you're putting into the blender, those are what would be your parameters, or in other words, inputs to that function. Then the process, basically what the function does, the blender, what does it do? It blends. So it's gonna blend the fruits together. then it's going to give you output, which is a smoothie or a juice. So that's exactly how a function works. So we need to tell C++ that, listen, I'm going to create a function, then I'll provide the implementation later. So we always put the function prototypes here, prototypes here at the top. Then after the last curly brace, we put in the function implementation. Basically, the function implementation is like, how does it do the blending? You're telling how it should do how it should blend or cut the fruits when the fruits are now placed inside the blender. That's basically function implementation. So let's create a function prototype, right? Let's say let's say you have a function, simple function. It's called add, we can call it just add or add two numbers. Let's call it add two numbers. So it adds two numbers and it returns them. Let's say it returns them. There's the return type, right? It's basically any C++ data type, even the one that you created yourself. In second semester, you learn how to create your own data types. Even first semester, you actually do technically kind of, yeah, you do. When you go to record structures, you're actually defining your own new data type. So any data type, even if it's a record structure, it's still a data type. Any valid C++ data type, that's the data type you pass there. There's a type that you guys haven't learned yet, or we haven't discussed, which is void. Void just means that the function does not give you back anything. Remember the output part. It's not always the case that functions give you back output. You just feed it in information and it does nothing. Basically, you don't get feedback. There's functions that do that. For example, a function to print. It shouldn't give you back any value. It'll just simply print to the standard output, right? So I'm gonna say this is I know it's gonna be a stupid function. Trust me, I know, but it's just for example purposes. So I'm gonna say print number because it prints a number. And then I'm gonna tell it takes in some parameter, right? So which is a variable. So you're gonna, in order for you to pass the variable, you'd have to tell C++ what data type that variable is. That's how explicit you need to be in C++. If you remember functions in high school, right? When you have functions like f of x, it has the equation x times 2. Let's say that's the equation. So if you wanted to find f of 1, right? This would be substituting 1 in place of x, which is just 1 times 2, which is just 2. So f of 1 would result in 2, right? Those were functions. That's exactly the same thing we're doing right now. Now the only difference is that f would be the name of the function. Then you have to say behind the f, what does the function give you back? In this case, this function returns a multiplication, which is a number. So we'd have to say int behind it, right? Because it returns a number, which is an integer. Then I would have to omit all of this. Then, okay, I'll leave the semicolon. Then x, C++ needs to know what is x, right? Not your x, who's probably the number one on the most hated list or that you have of people. Not your x, just the x, right? So what data type is this x? C++ needs to know. You can't just say x. It's just going to be like, what do you mean by x? So you need to tell it that this is an integer, right? So int x. If you have more than one variable, you can separate them by comma. So let's say you have int x and y. So you can have comma int y. If you have z, int z. So you can have multiple of them. Then you can put a semicolon there to create what we call a function prototype. A function prototype, right? You're basically telling C++, listen, this is how the function will look. I'll give you the process part, which is basically what the function does. I'll give it to you later. Just know for now, this is just a promise. Like, for example, when you promise your partner that let's say you have proper relationship goals, right? You have relationship goals whereby it helps better one another. You promise your partner, okay, if you get minimum 75% on semester test 2 for ComSci, I'm gonna buy you Ferrero Rocher. I'm gonna buy that last number, the big one. if you get 75% in the semester test 2. Then you get it, then if you get it, then you get the Ferrero Rocher, right? So this part here, this is you making the promise that you will do something. That's why if you just leave it like this here, C++ is gonna shout at you. It's gonna be like, why did you keep the promise? You said you will implement this function later. Why is it not implemented? So you need to make sure you make the promise first. So this is just a function that prints a number. So the number that we're gonna print is the sum, right? So I'm gonna say int, let me say total. Normalize using the word total because if you use sum, right, sometimes there's some function in part of C++ or max function. For example, there's a max function, right? You see, so you need to be very careful with how you're naming things. That's why I'm deciding to call it total. I don't like the way Dr. Stung names stuff like int total. I'm not a fan of that. Never been since day one. So I'm not gonna use that approach. If you feel like that works for you, you do that. You do you, boo. So this is void print number. So void, what does void mean? It means that you don't get back anything. It's like if you remember when you go to, most likely has happened to gens a lot because as gens we can't save money, right? So if you remember when you go to buy something and you had exactly 55 rand 30 cents in your account, then your balance when you get there to the till is actually 56 rand your total. And then your card declines. Then they're like prudence, void, yeah, decline, right? They always say void. If you try to pay attention next time, they use the word void. Why are they using void? Because on the computer screen it says void, meaning you tapped or you inserted the card and there was void, meaning we got back no money. So nothing was received. So therefore void. That's why that's the example that I like to use to make sure you remember what void means. So this is void. It gives you back nothing. Another word for give back in programming, we say it returns. If you look at this int main function, right? We said it returns an integer. Therefore, we use the word return. Then we return a number, which is an integer. If we are to return 0.0 like this, it's gonna crash. It should. Okay, let's try. Maybe it might. Yeah, C++ is unpredictable. Let me change this to a string. Let me do this instead. Maybe now it might crash. Yeah. So you see, it checks what this thing that you're returning here, it needs to be of the type that you told your function is going to return. So I need to put a 0 there. We explained what returns 0. Go watch the recordings. I explained all of those things. So I'm going to create a function called sum because there's no, lucky enough, there's no other function called sum inside of this inside of C++. So I'm going to call it sum. It takes in two numbers, x and y, and then semicolon because we need to end that statement. Excuse me. So remember, C++ is you need to be very direct. Don't go through the corners. It's going to ask you what is x. So you need to specify what data type. So you need to say int if it's an integer, then int if it's another int. Then there's something inside C++ that we call them default values, right? Basically, you can make a parameter optional, meaning that the user can provide us or they don't. If they don't, we give it a default value. So you can do this. You can say the default value equals to, let's say 10, then this will be equals to 32. These are the default values. That means, right, this is what it means. These parameters are optional, meaning you can either pass the number or you don't. All right, that's what it means. So I'm going to introduce you to this syntax so that you guys get used to every way of creating a function, every possible way. Then I'm going to copy the function prototypes, paste them down here. Then I replace every curly brace, right? Not a semicolon with curly braces. And then replace that semicolon. So now in this part over here, this is us fulfilling fulfilling our promise, right? Imagine that your girlfriend or your partner managed to get that 75%. Now this is you keeping your promise, buying them that expensive Ferrero Rocher. So yeah, I'm going to do this. Let's see. Yeah. So yeah, just lost my train of thought a bit there. So this function prints a number, right? So I'm gonna say cout followed by the number that I want to print, which is just this total. I know it's a stupid function, but I just want to demonstrate the void. That's my main goal here. I want to demonstrate void. Then you're done. This is the function. And make sure the code that you write, it's in between these curly braces. Because these curly braces, right, they tell C++ that all of the code in between the curly braces, you can call that code by simply calling the name of this function and passing a parameter. So that's why I need to make sure my code is in between these curly braces. You do spiritual things and you start writing outside, you're on your own. I won't be there when you're writing semester test 2. You're writing your own things that nobody taught you that are not even there on the slides. That's why it's important to do homework. When I give you homework, do the homework so that you make these errors now and fix them so that in the future, when you're writing semester test 2, when you, by mistake, maybe you're rushing, you're typing fast, then you make that error, that error, right? You see it instantly, like, oh, I know this thing. I got the error when I was doing sales homework. Yeah, I know how to fix it. Then you fix it. Done. But if you're trying to act like a screw, like you come from a wealthy family and you're not gonna take studying seriously, you're on your own. So let's implement the sum function. It does a simple thing. It adds up the numbers. That's all. So there's multiple ways you can implement this function. Number one, you can create a variable called total, right? There's something called scope, right? This total over here is not the same as this total over here. This total inside this function, right? It only exists in between these curly braces. The moment C++ reaches this curly brace, that's the end of the function. That's the end of the existence of this variable. But then when it comes to this function, and this is the start, this means this total only exists in between these curly braces. So it's a different total. So don't get confused. It's two different things. This is a separate function. This is a separate function. They're not related. Even if the variables are similar, they're not the same. So I'm just going to say int total is equals to x plus y because I just want to sum up the two parameters. Then I'm going to tell C++ to now give back the result to whoever is calling this function. How do I tell C++ to do that? I use the keyword return. Return, you can think of return, right? Is like, for example, this is how return works, right? For example, I give you, let's say you're attending a maths tutorial, right? And they ask you to write down the answer for 2 plus 3, right? Write down the answer. Then this is you write down the answer, you say is equals to 5. Then you give, say, the paper that you wrote the answer on. You see that process, that process, the moment you're handing him the paper, right? Your professor, that moment, that transaction of you handing him the paper to his hand, that's what we call returning. It gives you back the answer. In this case, the answer is 5. In our case, we don't know because there's a lot of possibilities here. Remember, I said these are optional, right? These parameters are optional. So there's many ways you can call it. You can pass only the first parameter and ignore the second one because both of them are optional. Or you can pass both parameters, or you can pass none because both are optional. So you see, it's all about understanding what you're doing. So this keyword return, it returns the total. But then you see that, do you see there's no use of the variable total? I don't use it elsewhere. So C++ or any other language, it allows you to sort of like take a shortcut. I don't see where you see the purpose of a variable, right? It's when you're going to use it more than once, like especially multiple times, like a lot of times. In this case, I only used it once because here I was declaring it. I used it once here. So yeah, it has no purpose. There's no need. You can just simply say return x plus y. Then you just simply delete this line. Then C++ will take the value that the user's passed here, which is this, and then add it to this value that the user's passed here. If no value was passed, remember we have defaults here. Okay, I forgot. If you try to run this will give you an error. Let me show you. Yeah, so you remove them here. You only put them under prototypes, right? Then under implementation, just leave it as X and Y. C++ knows. Don't worry about how we do link. That's none of your business. If I'm being frank with you, that's none of your business. You just need to understand that it works. Because if you try to understand why it works, you'd actually have to do computer science and engineering. So 2 degrees at the same time. So sometimes learn to mind your own business sometimes because you don't want to know how to get that answer. Imagine trying to do engineering and computer science degree same time. Like when I mean same time, like you register for them same time. How would your timetable look? So you see, sometimes some things you just need to understand the surface. Just it's enough to know, yeah, it's gonna work. That's enough. We don't need to understand why it works. Because to understand why it works, you have to take a screwdriver, break down your computer. That requires an engineer, right? So you need to do engineering. So yeah, just know it works. Don't ask me how it works, just know it works. So it returns the total of adding this and that. But then remember, this are optional, right? I can pass in 10. I can leave the parameters. That means it's going to use the defaults, which is 10 and 32. That means it's going to come here and say, this is 10 plus 32, which is 42. Then it gives me back the answer 42. So just keep that in mind. So let's call the functions. So I'm going to have here call the functions. So let's create the variables, right? So int x, comma y. If you have multiple variables of the same data type, instead of declaring them on separate lines, you can declare them on one line. You see, there's that int. It means int x, int y. Just make sure you put that comma there. Then you can also give them default values. I'm not going to get the values from the user. I'm going to put default values. So I'm going to say 350 and 350. You can use equal signs, right? That's up to you. Me, I prefer this way. This is a preference, right? You can do it in your own way. But they'll kind of advise you, professionals kind of advise you to use equal sign. So you can just stick to equal sign, but just know this is possible. So let's try to calculate the sum. So I'm going to call the sum function. How do you call the function? You provide the name of the function first, followed by the round brackets. And then you pass in the values corresponding each parameter. That's if there is parameters. Remember, it's not always the case that you're going to have parameters. It might be empty, no parameters at all. So it's not always the case that you're going to have parameters. And notice code blocks. It kind of helps you so that you understand which parameter to pass. You see, it's highlighting in blue int x, meaning that the first parameter that I'm about to pass, it's going to represent my x value in my function. So I just called it x again, so I'm just going to pass x. Notice something here. The moment I press comma, right, I put a comma, it's going to highlight the y now to tell me that now I'm about to pass in the value for y, which is just simply y. And then done, right? So there's my sum. But remember, this gives me back a sum, which is the addition of 350 and 350, which is 700. I need to store that 700 somewhere, right? Basically a variable. So I'm going to have int total is equals to this, because this gives me back, is going to calculate and give me back a 700. Then that 700, it stores it inside total. You might ask yourself, what's the whole purpose of functions if I can just simply add the numbers together? Well, the thing is, if you repeat a lot, if you have a lot of code that you're going to repeat, you'll notice that your code becomes untied. Everything becomes all over the place. So functions tend to make you write less code. So I'm going to store it that way. And to be honest, it's allowed, right? You can call this function like this and don't store the value in a variable. It's not going to crash. You see, what this does, right? It means you call the function and you ignore the value that it gives you back. So basically, you're not calculating the sum. I don't know why you'd want to do that, but sometimes it's the answer that's given back to us by the function is not important sometimes. So we can call it like a void function. Then we print that sum, which is stored inside the variable total. So I'm going to call print number, that function print number, round brackets, semicolon, then I pass in a parameter if it has parameters. The print number only has one parameter. So therefore, I'm going to pass in one parameter, which is total. Then now it's going to print the total, which is 700. So let me add a string here to make it a bit beautiful. The total is, yeah, that's a bit better. Then it's up to you if you want to use things like set precision, whatever. But in this case, we're only working with integers. So you see, there's my total 700 as expected. You might ask yourself, now let me show you let me show you the importance of a function. I can change y to 50 and it'll still work. So that's the nice part about the function. You can call it as many times with different values. So you see, this is 400. Now it updated because I changed the values. And remember, I talked about these parameters. They are both optional, meaning you can call it without them. Because why? You've given the parameters default values if they are not passed. So let me show you another example. So I'm going to ignore and totally not pass anything. So my output is going to be 42 because it's going to use the default values. You see, there's the answer, 42. So as you can see, I didn't lie. It works without the parameters because I taught you a technique. If the parameter should be optional, you can just initialize that parameter to some value, some default value. Yeah, and it also works with strings and every type. You can pass any type, you can return any type. It works the same way. So I want you to notice the difference here, right? You see how you call it a function that returns. You see that function returns. You assign the returned answer to some variable. A void for function, you see that you're not assigning because there's nothing, there's void. So what are you going to store here? If you try doing this, right, let me show you. If you try saying total error, because you are doing spiritual things, you should be there in heaven. That's where you belong if you want to do spiritual things. So void function, they don't return anything. Don't be putting them inside variables. They don't give you back anything. If you look at this function, is there a return here? Nope. So there's no need. And remember, we talked about the keyword return, right? It does two things. It leaves the function and it gives you back the answer, whatever that variable is, whatever that variable stores, or whatever that result is. You can actually call it in a, you can actually call the function in, you can actually use the keyword return in a function that doesn't return anything. So in this case, you don't return a value, you just say return. So let's say if my total is greater than 600, right? If it's greater than 600, then what am I going to do? I'm going to simply return, meaning I'm going to leave the function. So that means if my total happens to be greater than 600, it's not going to display the total. It's just going to simply exit the function. Because remember, everything is done from top to bottom. So it's going to read this part. It checks if this is true. If it is true, it returns or it leaves the function. Why am I saying it leaves the function? Because if you check after return, did I put a value there after return? No. Because if I try to put a value there, it's going to try to match that value with this data type, of which there's no type there. It's just void. There's nothing. So that's why I don't put anything there. So now let me update my thingy. Let me put back 350 here. So now the sum, and then I have to pass the parameters again. Now the sum is going to be 700, which is greater than 600. So therefore, it's going to simply leave the function before printing. That means there's no output. You see, it doesn't show me the total because the return keyword leaves the function. But what if I leave the parameters and then I use the default values? the total is 42, which is less than 600. So it should simply skip that if statement and go to the printing part, of which it does, because now I can see my output. So this basically functions. And then when it comes to header files, right? And if you remember header files, they simply store your prototypes. And then the CPP file simply stores the implementation files. Because why do we do that? Because if imagine there's like 600 functions here. Imagine 600 functions. Do you see that you might even forget where your main function is? You might lose track. Then you have to implement it. You can have a very big file. You don't put, there's this code. You don't put your, you don't lay your, you don't, is it, you don't lay or you don't put, but it's something along those lines. You don't put your eggs in one basket, right? So don't put everything, don't force everything inside one file. Create the separate files that store other code, then just simply use this technique of hash include, which is preprocessor directives. So yeah, that's it for today's tutorial. So we'll see you tomorrow. We're gonna talk about, tomorrow talk about loops. I think I didn't mention, I think we didn't do loops. So tomorrow we'll do for loops and record structures. So for loops and record structures. So that's it for today. See you tomorrow.